Hi, this is Mrs. Schaefer, and I wanted to go through lesson 1.04 and 4.01 and 4.02 on atoms. We're starting to dig a little bit deeper into atoms and what they look like. You can pause this video at any time to help you review what is on the screen in order to get a better idea of anything that you missed, or you can pause and go through any of the videos that you can find in the lesson material. So please remember that you want to focus back on that goal. Go back at the end of every chapter and focus in on the goal in the lesson 4.01.02 lesson material. These links are lives to help you out so that you have no problems uh, completing and figuring out what you need to do for your grades. So there's the extra credit link on how to get extra credit for every um, unit test. You'll fill out the top here with your goal all the way across, and then at the end of every unit test, you'll put your actual goal and compare it with the goal you set. If you didn't hit your goal, you'll specifically list things that you can do, like restudying the review sheet or redoing a lab, going back through the lesson material, just very specific things that you can check off your task list. If you can't check it off your task list, then it's not specific enough. But there's also a link here that will show you the points and how they line up, and you can kind of gauge how you're doing, where you need to adjust. Both of those are available to you if you would like to use them. So we're going to start talking about the atom, different parts of the atoms, and also isotopes, looking at our review sheet number 1 and 2. Anytime you're stuck, you can come back to this chapter and start checking it off. This is like a task list. Check it off. Can you do it? If you can't, go back into the lesson material and look for that information. So you can use this to help you as you progress through the more challenging parts of the lesson. Anything that's missing is labeled there. You can go back, review as often as you need, whatever it takes to help you master the material. All right, so atoms are the building blocks of matter, kind of like Legos are the building blocks for this giraffe. Atoms are the building blocks of matter. Atoms are put together. If they have the same atom, then it's an element. Those elements or atoms will combine to form molecules. So just like one small Lego piece built together makes a very big giraffe, atoms come together to build, they connect through chemical bonds and will build up large molecules. All right, so there is a video that you can watch on what is an atom in the material, but basically here's the skinny of it. So atoms are built up of protons, neutrons, and electrons. They have charges and they are found in specific areas. So the protons and neutrons are found in the nucleus or in the center. Electrons circle around the nucleus. Positive protons, neutral neutrons, and negative electrons. So those electrons are in constant motion around the nucleus, and the atoms are held together in molecules, so they bond with each other. It's the electrons that will bond with each other, and that's what allows the atoms to kind of hold together, like that Lincoln or those Lego blocks or Lincoln logs. They connect and they hold themselves together that way. Well, but that's the funny thing about neutrons and protons is they're called nucleons because they're made up of quarks. Now, this took a while to discover, so this is a newer idea, But quarks are the fundamental particles that have a strong nuclear force, and that's what brings the nucleus together. So you can see here a proton is made up of 3 quarks, and a neutron is made up of 3 quarks, and those protons and neutrons will come together in the nucleus. Again, the electrons are still circulating around the nucleus. And you can see some sizes here as comparisons to help you out. So an element is one specific type of atom. It also means that it cannot be broken down by chemical processes. That's as far as an atom can go. So I could take some aluminum foil, which is 98% aluminum, and keep ripping it smaller and smaller and smaller, and I still have aluminum. I can keep, even when my fingers can't tear it apart, I still have atoms of aluminum stick together. Those are it's called an element. Those atoms are called an element because they're all the same type. So an element is made up of the same type of atoms. We can't see atoms directly though. We do have some models to help us out, and that's what we're looking at is the model. So this is a model of a atom. We have already talked about their relative charge, and their mass is based on how big they are. So protons and neutrons are about a mass of 1, and electrons have about a relative mass of 0. So you can see how small they are. So they're pretty small units. We can't measure them in grams. It's really awkward. So we call them atomic mass units. And so we'll talk a little bit more about that. But again, as a reminder, you want to have this in your notes because it's got the nucleus and the location and the electron cloud. So there's a lot of different things, size comparison that you can use to help you out. But electrons are very small. The majority of the space of an atom is empty. It's empty. You have that nucleus in the center, then you have the electrons around the outside. We get and organize our atoms so that we can keep track of them based on the number of protons. So the atomic number is the number of protons in an atom. So we just count them up. So up here you can see that with helium there are 2 protons, so its atomic number is 2. If an atom is neutral, it means it has the same number of protons and electrons, because the positive charge, negative charge, they're going to total each other out. Neutrons don't have a charge. So we have this idea that a positive and a negative, to get it neutral, it has to equal 0. If it doesn't equal 0, then it's not neutral. Most times we're going to say that an atom is neutral unless we tell you otherwise. Here's the idea about carbon. You can look at this, try this out. Here's a sample. You'll see that it's not neutral because the charges don't match. All right, so reviewing, we can create charged particles based on if they have a more electrons or less electrons. So it can be called an anion if it is gaining and cation if it's losing. So we can use that information to help us. We will be talking about that. Again, atoms are like that individual Lego. A molecule is like the entire giraffe. Well, we can't see these, so how do we figure out all this stuff? Well, it's kind of like our wrapped present. You know, sometimes you've gotten those Christmas presents and when you're younger, you're trying to figure it out and get clues. You'll shake it and try to determine what it is. Well, that's what scientists did, is they're trying to determine what the atom looks like. And so they've created models. Models are just explanations of what they think it happens. And you'll want to pause this, and there's a video in the lesson material, but you'll see how the atom developed through different models. And you'll also notice that we lots of times use the Bohr model down here in our class to help us identify the electrons and talk about bonding. But really, this is what the current model, it's called the quantum mechanical model or the electron cloud model, whichever, is probably more like. And that means that the nucleus is in the middle, and all these green dots are the probability of where an electron could be found because it's in constant motion. Well, how did they do that? Well, they took a lot of pictures. Just like here on the model, which you could pause and read and see, they took a lot of pictures of an electron of where they could be, and then they have the probability of where it could be found in the area. So that's a lot. There's a lot of information you'll learn in chemistry about that. It's really kind of cool to see how it works. But for our system, what we do is we use models or drawings to help us learn about them. There is an extra video too in the lesson material. It's really cool about what the atom really looks like, so check that out. Remember the charge in the nucleus. Well, what happens if the numbers don't all match? What happens with the idea if the protons and the neutrons are different in the atom? So that's called an isotope. An isotope is an atom of the same element that have different number of neutrons. Remember, if it has a different number of protons, it's a different element. But if it has 12 protons and 6 neutrons or 7 neutrons, it's still the same atom or element. It just has a different count. So those are called isotopes. So the chemical properties of an isotope are the same. So carbon 12, carbon 13, same chemical properties. But their physical and their nuclear properties are different. So for example, nuclear properties of carbon 12 is that it has 6 protons and 6 neutrons. The nuclear property of carbon 13 is that it has 6 protons and 7 neutrons. So isotopes with more neutrons are going to be heavier than those that have less neutrons. There is an example explaining that in the lesson material too. Here's a picture example of the 3 isotopes of hydrogen. So you have protium, deuterium, and tritium. So notice that the difference is the neutrons. 0 neutron, 1 neutron, 2 neutrons. And these are called isotopes of each other because they both, or all 3, have only 1 proton. And it's the proton that determines the name of the element. So you can study through some of this. Please remember, keep this in your notes, that the key idea is the protons tell you its identity. The neutrons will tell you which type of isotope it is. We name them just like this, 6 protons, 6 neutrons. Can you figure out what we would call this carbon model? If you can see that carbon 13 has 6 protons and 7 neutrons, carbon 14 has 6 protons and 8 neutrons. This is how we label it on our symbols. You will want to look at that diagram. There's a lot of different ways we represent our material to help us out. So go ahead and look at this information to help you out. There is some practice questions if you'd like. If you have any questions or concerns about anything, please let me know. Check out the SAT and practice questions to help you as you prepare for the PSAT and the SAT. Have a great day. We'll see you next time.